Hi, everybody. Thank you for joining us today. My name is Omer Raviv, and today I'll be talking to you guys about Visual Studio debugging tips and tricks for the new Visual Studio 2019. I will first introduce myself. As I said, my name is Omer. I'm the creator and CTO of Ozcode. And today we'll be focused on a very, very technical session. We'll be going through different features that the great folks over at the Microsoft Visual Studio Debugger team have added to the latest release of Visual Studio that will help us debug, diagnose, and root cause our bugs much more efficiently. Let's take a quick look at the agenda here. So today we'll be talking about several new features in Visual Studio 2019. We'll be talking about data breakpoints, which allow us to break into the debugger when state of a property or a field changes. We'll be looking at the new search functionality in the Visual Studio Watch window, and we'll talk about everybody's favorite feature, Visual Studio LiveShare, and in particular how that relates to debugging. Finally, we'll have a bit of time at the end to do Q&A, so if you have any questions as I go through the presentation, go ahead and put them in the QA tab here, and we'll be sure to address everybody's question in the end. Very much encourage you to make this interactive and ask me anything you'd like at all about these cool new features. So with that, without further ado, let's start looking at the new stuff. And I'll start by talking about data breakpoints. Now, what are data breakpoints? If you're an old-timer native C++ developer, then first of all, my condolences. And also, seriously, you actually lucked out because you already know about data breakpoints. Data breakpoints is basically the ability to tell the debugger, I want to break when a particular value changes, rather than a usual breakpoint, which we put on a line of code. And that's particularly helpful when we're dealing with the most nasty bugs where we're dealing with mutating state, right? I had some property, some object, and all the properties were fine. Everything was all great. And then somewhere along the program's execution, something bad happened, and that state mutated into a value that was corrupt or incorrect in some way, and then everything crashed. But I don't know where, why, and how that state mutation happened. Now, if we're dealing with multi-threaded code, that just becomes even more complicated because now we don't know which one was the thread that actually changed the property, when did the other thread attempt to read that corrupt value, did the problem happen because different threads were trying to access the same data at the same time. So this is really, really hard. So let's look at how data breakpoints in Visual Studio 2019 can help us. So you see I have a super simple bit of code to explain this super simple feature. I defined a class person with a field that's an age, and I call some person transformer class, which is probably doing some weird stuff, but I'm not sure where exactly it's changing this state. Now, the first limitation you need to be aware of is that data breakpoints will only work with .NET Core, and not only that, they will only work with .NET Core 3.0, which is currently in preview. So if we go ahead and attempt to do a data breakpoint right now, you'll see that we can't. So I'll go ahead, and the way you do a data breakpoint is you try and hover over the variable, you open up the property or field that you actually care about, and you say break when value changes. Now, in this example, Visual Studio is complaining and they cannot specify an address. Data breakpoints require .NET Core 3.0 and up. So no problem. Let's just go ahead. And I need to do two things here in order to play around with data breakpoints. First thing, I need to go and change this to .NET Core 3.0. And if you haven't used .NET Core 3.0 before, you'll also have to go into Tools, Options, .NET Core, and make sure this checkbox is checked. It says use preview of .NET Core SDKs. Otherwise, you can't run .NET Core because you have to first approve that you're okay with running a preview and playing around with the bleeding edge early access bits. But now that we've actually done that, I'll run the program again. I'll hit my breakpoint, and I'll say I want to break on this property or this field. I'll just, again, hover over this guy, go into age, right-click this, and say break when value changes. Now you'll see now whenever I hover over this value again, you'll notice two things. First, you notice that there's an actually breakpoint on the field itself, not on the line of code, but on the field. So no matter where in my code base this property or field is changed, we will break there. The second thing you'll notice is this $1, and this $1 is an object ID. Now, if you've been using Visual Studio for a long time, you may or may not know about object IDs. It's actually a hugely productive and powerful feature that's been in Visual Studio Debugger for more than a decade, but very few people actually know about it. An object ID is just the ability to create a unique identifier on a particular object. And once we have an object ID, and you can always go to any object in the debugger and say delete object ID or make object ID, and I'll go, sure. So let me make the fonts bigger for you. There we go. So once we have an object ID, we can go into the Visual Studio Debugger and type in that $1. So every time I create an object ID, it makes an unique identifier, so it will be $1, $2, $3, etc. And whenever I hover over this variable, no matter in what context, even if I run the program forward, as long as it's the same exact object, I'll see this unique identifier show up. And now, when I run the program forward, now that I put that data breakpoint on, boom, it took me to the line of code where we actually do weird stuff and change the age, and it's telling me the following breakpoint was hit, and the breakpoint is when age on $1, and again, that's the particular person object that we wanted to see when we're changing its state. It was changed, the previous value was 5, the current value was 20. So there you go, that's data breakpoints. An interesting thing, by the way, is that you might wonder how come it took them so long to make this feature in Visual Studio, since C++ developers have been enjoying it for so many years, for more than 15 years. The reason for that is that the way data breakpoints work is they tell the CPU in C++, they just tell the CPU we want to change when a particular memory address is set. However, in .NET, our objects in memory are constantly shifting around, right? The garbage collector does compaction. And so this person object might be in different different places in the managed heap throughout the execution of our program. The new .NET Core 3.0 natively supports dealing with that tracking so that data breakpoints actually work, and that's how this magic happens. Now, .NET Core 3 isn't out yet, so the fact that you need .NET Core 3 is a big limitation. So if you're using Ozcode, you don't have this problem because Ozcode has a feature called when set break and when set trig, which actually has been around for about 4 or 5 years. So if you want to do the same thing that data breakpoints give you, but you want to do it on .NET Framework because you're still working with WPF or WinForms, just use the Ozcode when set or when break feature, and you can use that in any type of application. Alrighty, so that was data breakpoints. Let's move on now and look at another cool new feature that Microsoft have added, which is the search functionality. So search is extremely useful because in some situations we're debugging and we're trying to find a needle in the haystack, and the amount of work we have to do in order to find that needle is just excruciating and so frustrating. Let me give you an example. Let's say I have a customer's object here. I put it into the Visual Studio Watch window, and I open it up, and I see a big list of customers, and of course nobody bothered to implement toString on customer. And I want to find a customer named Michael. Now, there are several things I could do here. One thing I could do is just open this one up and say, is this Michael? No. Okay, let's see the other one. Is this one Michael? No. Okay, let's see the other one. And this Michael? No. Okay. And that's pretty much how I lost all my hair. So that's one option, and it's hugely annoying. That sucks. The other option, of course, is to stop the debugger and then write some code. Like I could add an if statement here. If customer.firstname equals Michael, and put a little breakpoint inside that if statement. Now, the problem with that approach, in my mind, is that it breaks down our inner loop, our feedback loop as a developer. When we're debugging, in my opinion, one of the best ways to be efficient and productive is to be mindful and be conscious of what we're doing in order to gain more insights. One thing we could do, we could, of course, stop the debugger, write more code in this if statement, but then we'll sort of lose focus, right? Debugging should be about forming a hypothesis, why we think the code is not doing what we think it should do, then either proving or disproving that hypothesis, and then moving on to the next hypothesis, perhaps writing a bit of code to try and confirm or deny that the hypothesis is true, and then repeat that cycle until we're done. Now, when we're stopping in the middle of the debugging session to go and write some code just to find the person named Michael inside the collection, we're breaking that feedback loop. We have to stop the program, add a bit of debug-only code or a bit of logging, run the program again, do all the things we need to do with the mouse and the keyboard in order to get the breakpoint to hit again to reproduce the bug, and only then can we actually make one more step towards understanding the true root cause of the bug. So luckily, Microsoft have added a search functionality. So now I can simply type in Michael, hit enter. Takes a bit of time, but then it will eventually find that field and property that have the word Michael in them, and I can scroll through all of this, which is very nice. And you can actually search not only based on the value, but you can also search based on the property name. So if I type in, for example, gender, I can very easily skip through all the different gender properties and see the results very easily. Now, you'll also notice that there's a search depth value here that I can play around with. It can go up to 10. And search depth just means how deep into the object graph we want to go. So we could go 2 or 3, etc. So basically, how many of these little pluses do we want to expand? Now, one limitation of the search functionality is that it only works through the autos, locals, and watch windows. So you can't use it in the data type window. And that's really unfortunate because for me, personally, when I'm debugging, I like to hover over things, get the little data type window, and do that to look at variables. Now, luckily, if you're using Ozcode, Ozcode has had a search functionality for the past 6 years, and I can do the same thing. I could type in Michael. You'll notice that the Ozcode search functionality has several advantages over the Visual Studio One. One thing is that it gives you auto suggestions. So I just started typing in Michael, and it's already telling me there's a Michael 4, there's a Michael, there's an email address with the word Michael in it. And I can, of course, not only skip through the results like this, I can also filter the results down to see only the filtering properties that have the word Michael in them. One more very nice touch we've added in the Ozcode search functionality is that after you perform that initial search, Ozcode has already indexed through all of the data inside of this collection. So now if I just type in, for example, the word female, you'll notice that it's actually giving me some quantitative insights into the nature of the data here. So it's immediately telling me, oh, we've got 12 hits for the word female. If I change this to the word male, it will immediately, once I lift my finger off the keyboard, tell me, oh, we've got 18 hits for the word male. So it's a very quick and easy way to understand the quantities at play. So that's a little bit about the search functionality, another really cool feature that Microsoft have added and accessible through the watch autos and locals windows. Alrighty, and now, without further ado, I'd like to go ahead and talk about Visual Studio LiveShare. Visual Studio LiveShare, to me, is one of the most exciting features in the past decade or so of Visual Studio releases because it fundamentally changes how developers approach collaboration and working together on a bug or a feature. And what is Visual Studio LiveShare? Visual Studio LiveShare is simply the ability to invite a colleague or friend to my local Visual Studio environment. And it's sort of like a Google Doc for the IDE. They can share your same code right inside the same solution and debug the same breakpoint. Now, why is this hugely powerful? Well, the first thing and the first reason is because, well, developers and the development is changing. It's becoming more social. It's becoming more collaborative. I might be trying to solve a problem where inside of a legacy code base where I don't understand, the architecture that was implemented so many years ago, and I might have problems understanding what is the best solution to a particular bug or a particular issue. The other thing is that I might be trying to solve a bug and finding out that actually it's in part of a feature that my colleague wrote, and I don't understand the thinking process behind their design, their architecture, and just need their help to understand what's the best possible solution. Another reason is just that development is changing in the fact that we're now doing more remote work. People are working from home more often. And of course, the most important reason is something you just really don't feel like getting out of your chair and going to the other room. So you don't need to do that anymore. So to illustrate LiveShare, let's pretend that I'm one person on the left-hand side here, and another person is logged in from a completely different country. So person A on the left might be in China, person B on the right-hand side might be in New York, and the host can simply hit the LiveShare button to create a collaborative session. So this goes off to the cloud, creates a new session, and we automatically get a link pasted in, and then we can send it over email or Slack to somebody else. And then they can just go into File, Join LiveShare Session. It will immediately copy whatever is on the clipboard, and I can hit Join. Now, what's happening now is that we are joined in on the same session. We can see the same code, and we can also, the guest that's joined in the session can actually go inside of Solution Explorer. Now, what's interesting to understand here is that this doesn't actually, this is not screen sharing, right? What's being sent over the wire is not the bunch of pixels that represent the picture that you're seeing inside of your code here. It's just sending the minimal amount of bytes that it needs in order to create the illusion as if we're using the same IDE. So if I now just go in and double click on a different file, I will see that file, and you'll notice that this person over here might be looking at a different file completely. And this, in my mind, is perhaps the most wonderful feature in LiveShare, in that it enables a new type of collaboration. It enables these micro dependencies. So I could go look in some file, the other person could look at a different file, and we might go and venture off into different places in the code base to understand different pieces of architecture or pieces of design. And then once we've each drawn our conclusion and we want to go back to working together, one person might just pin themselves to the other person. So I could pin myself as the guest to the host by simply clicking this button. And then wherever the host goes on the left-hand side, I will go. So I can switch between different files. The host will also go into different files, and we can very easily see the same thing and work on the same code. Now, where this notion of micro-dependencies and working together and then splitting off is becoming even more important to my mind is when we're debugging. So let's look at debugging with LiveShare. So as the host, I will hit F5 to start the debugging session. And you will see that both the host and the guest will now hit the same breakpoint at the same time. Now, what's really interesting about this is that I can now collaborate in a different way than you usually can collaborate when you're debugging. What do I mean by that? Well, when two people are staring at the same computer screen and trying to debug the same problem, they constantly run into this problem of who's got the steering wheel, right? So one person might, the person with their hands on the keyboard might hit step into, while the other person would be like, wait, I still need to understand what was the context, what was the call stack, how did we get here? And then one person might hit F10 and step over a line of code, and the other person might say, wait, I wanted to see what the state of that variable was before we stepped over that line of code. And this just gets hairy because different people have different ideas of how to go about debugging, what they'd like to explore first, et cetera, et cetera. So with LiveShare, there's a new way of doing work. And this is part of the Ozcode LiveShare integration. So the Ozcode team has actually worked very closely with the LiveShare team on the LiveShare SDK over the past year, and we're very proud to be one of the, or actually the first extension vendor to make an actual integration with Visual Studio LiveShare as part of the Visual Studio 2019 SimShip. And what does the LiveShare integration do? Well, with Ozcode version 4.0, the same version we released on the same day that Visual Studio 2019 came out, we've added this notion of time travel debugging. So as I hit this breakpoint at the very beginning of this method, Ozcode has already predicted the entire execution of this method. So now you'll see that there's this little annotation next to the for each loop telling you that there are 30 items, 30 iterations of this for each loop. And of those, 18 went inside of this case clause, and of those, 7 went inside of the if statement, whereas 11 went inside of the else clause. Now, when I actually hover over this adornment, it actually shows me what those 30 iterations are. And by simply clicking on one of these annotations, I actually time travel to that particular iteration. So I can see, for example, that in this iteration, we went inside of this case clause, and the if statement returned false because all these sub-expressions were false. That's why this is painted red. If I go to a different annotation, we see that actually we ended up in this switch statement, switch case, and so the irrelevant code was de-emphasized for us. Now, this gets back to my point about collaborative debugging with micro-independencies, because the host on the left-hand side might go to a completely different iteration and explore what happened there, and can time travel to different points in time and make different conclusions, and we can work independently of each other as we're debugging with time travel. For example, the host might go into this iteration and see that, oh, here the if state, the first predicate here returned true, and that's why the rest weren't even evaluated. And of course, when I hover over variables in this time travel mode, I actually see the values that were related to the current context. In this case, the context is the fourth iteration of the loop. One more very nice thing that we can do here, and I can do this as both the host or the guest, is I can use the if statement analyzer to actually go and see what were the different iterations that we had here. So I can see which were the iterations that where the if statement returned true, which were the if iterations which were the iterations where the if statement returned false, and then of course this also acts as a pivot for my time travel debugging experience. I can click on any iteration here and time travel to that particular moment in the program's execution. So this was a quick look at Visual Studio LiveShare and of course the Ozcode integration on top. So if you'd like to learn more about the Ozcode features that I showed you today, you can go into our features page to learn more, or the Get Started page to check out some videos. And of course, we'll also be sending you lots of resources about the Visual Studio features that we've discussed today and the Ozcode features as well in our thank you email that we'll send you early next week. So if you have any questions as we are reaching the end of this webinar, please let us know, write us in the Q&A portion. I'll check out if we got any interesting questions. All right, I see that we're good on questions. So with that, I'll say thank you very much, everyone. It's a pleasure to be chatting with you guys, as always. We look forward to hearing from you, receiving your questions or feedback on this webinar, and looking forward to seeing you on the next webinar. Thank you very much and have a great day. Bye-bye.